Now this is a special factoring lesson because I've called it freaky factoring because number one, it's going to look like the craziest kind of factor problems you've ever seen. I mean, let's take a look a little bit ahead. You guys ready to factor something like this? But it does come from a calculus technique that will produce this kind of an answer, and so it's going to be important that you know how to clean it up so that it's more user-friendly. And so in this technique, the thing to remember is even though they look crazy, we're really just doing greatest common factor factoring. That's all it is. It just looks a little weird. So let me walk you through it. We know how to factor this. I know you do. Very simply, we go look at the coefficients, 15 and 20. What can we take out of both 15 and 20 as a factor? 5 goes into both of those. That's a GCF. Then you move to the next kind of factor, which is the x factors. We have a 5th power of x here and a 4th power here. So common to both is the lower power, which is the 4. We can take out an x to the 4th. And the y factors, we move to that type of factor. So as we see a 3rd power of y and a 4th power of y, it's the smaller of the two that's going to be common. So it's going to be y cubed that we can take out. And then we always write down this parentheses for the quantity that's left after the GCF has been pulled out. Let's do that term by term. So 15 divided by 5 is going to leave 3. We've taken out all but one of those x factors. We had 5 and we took one of them out. So there's still an x in there. And all of the y factors have been drawn out in the GCF. Now the next term, we would take the 5 and divide it into 20, knowing that would give me a 4. All of the x factors have come out. We pulled out all 4 of those. And we had 4 y factors, but only took 3 out. So there's still this y remaining in there. And you guys know how to do that. That's just your common GCF factoring. It is the same thing when it gets crazier. So here's an example. Both of these, by the way, come from a calculus technique that you'll be learning next year. And it's your job now to clean them up by factoring them. So in this one, the greatest common factor, and I'll start just like before. What's common to my 63? And then clear over here in this term, the 72. Now remember, the terms are separated by the addition that we see right here. So 63 and 72. 9 goes into both of those. Let me write that down as my constant. Now I move to my next type of factor, which is just this pure x factor 8 times. I'm not saying that well. It's x to the 8th power. And do I have an x power over here? I do. I have x to the 7th power. So I'm going to take out x to the 7th as the smallest of the two exponents. And then I move to my next type of factor. So just like we were doing here, we move to the y factor. This factor is just a binomial. We have this binomial factor, x minus 5, a 6th power of that. Do you have the same thing in the other group? Sure I do. X minus 5 right here to the 7th power. So I'm just going to pull out what's common to both of those. And I have a power of 6 and 7, so I can take out common the 6th power. So I write this quantity, x minus 5 to the 6th power. Then, and I'm going to do a bracket here rather than a parenthesis because this is going to get kind of messy. I put a bracket down for what I have left in each factor. So what's still, when I look at the first term, all of this stuff here, this set of factors, what's still in there? Well, the 63 had the 9 factored out, so there's still a 7. The next factor was x to the 8th, and x to the 7th was pulled out, so there's still an x. And I took all of the x minus 5 quantities out because I had a 6th power, and that's exactly what I pulled out. So there's just this 7x remaining in there for the first term. Bring down that addition sign and go to the next term with the same question. 72 had a 9 factored out of it. 72 divided by 9 is, gosh, what is 72 divided by 9? I think it's 8. I'm crossing my fingers. Had a little brain freeze there. All right. X to the 7th is the next thing to consider. I pulled out x to the 7th, so there's no x factors left. And then I had the quantity x minus 5, and I only took out 6 in the GCF, but I had 7. So I still have that quantity left. And I close my bracket, and this is the GCF factorization. So all of this has been pulled out, and there's just one more step to do, which is to look at this leftover quantity, and we're going to simplify this. We're going to clean this mess up. So that's just, let's drop the parentheses. I'm going to distribute the 8 in, which will be 8x minus 40. Bring down my 7x. Let me close that up. Now those brackets just turn to a parenthesis because I'm fickle that way. And then combining like terms, I have a total of 15 x's plus or minus, excuse me, minus the 40. And don't leave this GCF behind. You want to make sure that's part of your final answer. And I'm going to box this because this is my final answer. So that's what that factorization looks like. And in calculus, this is what we get after we do our technique. It's known as the product rule if you want to ask your calculus friends about it. This is the answer to that, and then we need to make it more useful by putting it into this factored form. So we often go through this step of freaky factoring. And that's kind of it, but of course you're going to see some more examples. So in exercise 2, this is more than just factor. The directions ask us to also, well, actually find the zeros. So we're going to do that by factoring. And then we'll set each factor equal to 0 and solve as we have before. All right, so there is one little step that you'll want to do. This is what happens after the calculus students get finished with it. But then they would like to take a step, and I think it's smart to look at the first group of factors just here, and there's the plus sign. That's separating the two sections. So we've got one section of factors and a second section of factors. Look at the first section of factors, and I notice that there are two factors that are just single term factors. Nothing being added or subtracted like this one. So this is not what I'm talking about. But I'm talking about these two factors right here. That 4 and that 5x cubed, you probably just want to do a simplify step and multiply those together, which would be 20x cubed, and then bring everything else down. That will make things a little easier to be organized with. Now, same question here. I don't see any single factors that I'd be putting together. I would just bring this down. And then your next step is to find all the common stuff. So you've got two sets of factors. Out of this first set of factors and this second set of factors, let's start with the coefficients, 20 and 15. So 5 is a common factor of those. Moving to the x factors, I have squared and cubed. The smallest is the one that I can pull out, so it's going to be 5x squared out here. I'm just building my GCF. Then I move to this quantity factor, the x plus 7 quantity, and I see a third power and a fourth power. So it's the smaller one, again, that can come out. So it's x plus 7 cubed. Now I write a bracket to write down what's still in there. And I'm going to show you a little cross out technique that might help you keep track of everything you're doing. So when I factored the 20 and I pulled the 5 out, what was left? Sometimes people like to cross out that and write the 4 that would be left. So it's 5 times 4. I know we've been just marking it down here. I'm going to put it here anyway. The x cubed had x squared pull out of it. So x cubed lost 2 of those. That means it was just now x to the first power. So the x to the first power is what's in there. And this quantity cubed was all taken out. So all of that was taken out. And people like to do this cross out method because it lets them see what's still there, the 4 and the x to the first power. So let me bring that x down. The first term is just 4x now. Now using that same cross out method, let's talk about this factor. So 15 divided by 5 is going to leave a factor of 3. I'll cross that out and put a 3. X squared divided by x squared is going to just cross this all out. It was all taken out. And then the quantity factor with 4 of them and 3 were taken out. So this is now down to a first power. So looking at what's still there is the 3 and this quantity to the first power. Bringing down the plus sign, the 3 and the quantity. This is my remaining factor. And I'll close that bracket. Let me actually color that blue. All right, now you're not done until you clean this up and until you find the zeros. So we've got a couple more steps to go. Let's clean this up right here. So let's multiply the 3 through so we can drop parentheses. That's 3x plus 7, and the 4x is also in there. All added together, we're looking at 7x plus 7. And let me bring everything else down. 5x squared and x plus 7 cubed. All right, so that is the factorization of this function. Now, if you would like to pull the 7 out of this from this point, you're welcome to do that, and I probably actually would do that. But we're not finished till we find the zeros, and I'm ready to do that actually. So finding the zeros means we're going to set this equal to 0 and find all the x values that make that true. So factor by factor. I'm going to start with x squared, and x would equal 0 in that case, and it's the squared. So I'm going to just note the multiplicity of that, that would be a double multiplicity solution. This factor would let, x would have to be -7 to create a 0 out of that factor, and multiplicity-wise, it's got a multiplicity of 3. And finally, this factor, if I go 7x plus 7 equals 0, then you can do the algebra there. X is going to equal -1. So these are my zeros. So my answer would be that the zeros are, I can't spell zeros. The zeros are 0, double multiplicity, -7, triple multiplicity, and -1 would be my answer. Calculus students want to know these zeros right here. This is major stuff. So that's the goal of this kind of lesson, to prep you for that. All right, let's try another example. I hope you understood that crossout idea. It's just a technique, and you can use it or not use it. I am going to try to explain it a little bit again here. Before we do anything, let's look at the sets of factors. This plus right here is dividing your two sets. So just take this first set, and if you see any multiplications that should happen, things that are single factors like x to the 5th and 3, and at the end here 6x, just those single terms, let's multiply those all together. So 3 times 6 is 18. X to the 5th and another x here is going to make an x to the 6th power, and then our quantity that's got the couple of terms in there. I'll square it out. Okay, is there anything on this second set that we could join up? I don't see anything. Nothing's going to simplify here. So I'll just recopy that. All right, now let's take a look for the GCF. What can we find in both sets of factors? 18 and 5, that's my first one. And I don't think anything was common to 18 and 5 as far as factoring goes. So I'm going to leave that. X to the 6 is next. X to the 6th and x to the 4th. You can take out the smaller of the two. So I can take out of this an x to the 4th power. And I'll do that. I'm going to cross it out because I took it out. And I'm going to cross out 4 of these, bring it down to 2. That's my remaining factor now. And then finally, I will move to this quantity that I do see appearing in both sets of factors. A power of 2 versus a power of 3. The smallest can come out. Let me jot that down as part of my common factor, and that's going to be squared, the smaller one. Then I can say, okay, I took this out, so it's gone. And I took out 2 of these, so that's just down to a 1, just the single power, and I won't write the 1. All right, it is leftover time. So now that we have crossed out everything we took out, what do we still have? The first group sees, I see an 18x squared, and that's all that's left in that group, 18x squared. Over in the second group, I still have a 5 and this quantity with no exponent other than the 1. So that's my leftover factor. And this is the one that typically needs a little bit of cleanup. You got to simplify this. These guys, these are just coming along for the ride from here on out. All right, let's multiply the 5 through. It's going to be 15x squared minus 5. And bringing everything else down. Oh, I get to join these up. So, well, I don't know, 33x squared sound good to everybody? Minus 5. That's a factor. All these other factors are going to come down. Don't leave those behind. X to the 4th and 3x squared minus 1 squared. Okay, so there's the factored form of that crazy calculus polynomial. We want to know where it equals 0 usually. When you're doing calculus, that's a really important question. When does something equal 0? And so now that I got my factors, I can just ask that separately. So x to the 4th is going to equal 0 if x is 0. And multiplicity-wise, we're talking times 4. That's one of them. Make an adjustment there. The next one is this one. So when does 3x squared minus 1 equal 0? That's, let me just start moving stuff around here. That's when x squared would equal positive 1/3. You can check that, which means that x is going to be either the positive or the negative square root of 1/3. right, so that's two different answers there. But remember, your original factor had that squaring power on it, and so both of these answers have multiplicity that's going to be double. All right, now my final factor, that's going to generate some zeros as well. So let's take a look at these. X, or 33x squared minus 5's got to equal 0. So let's get x squared alone. That's going to mean x squared is going to equal 5 over 33. And that would give me an x value of positive or negative. Two different answers there. 5 over 33 square rooted altogether. Make sure that square root drops all the way down across that fraction. Was there multiplicity on this one? We refer back to the original factor of it. That was just single multiplicity. So these are my answers, and I'm going to circle them all. These are my zeros. And then you could graph it and have a good time. We're not going to worry about that. That's your zeros. Okay, one final example in this lesson. Here on the back is just a test to see if you're getting what I'm saying here. This one is seriously crazy. I have my calculus students do this. They generate this, and that's a relatively easy step. You won't know it right now, but just understand this is the easy part as far as getting this. But then the cleanup, they always want to send it over to you guys, pre-calc students, to clean it up for them. So now that you've got a little training in it, maybe you could, I don't know, they can hire you, pay you $10 to do their simplifications. Okay, before I begin too much, I'm going to do the check. Can I combine any of the factors because they're just single factors? That 3, that 2x, those simple little monomial factors. I'm going to do that. I'm going to make that 6x and put it in the front. And then I will bring down these other factors that I have. So let me just carry all the rest of it down. That's that x squared minus 2 to the 9th. That's crazy. And x squared plus 7 squared. And we jump over to the second set of factors. And here we do have another chance to do just a little simplified step. See these single monomial factors, single terms? Let's put those together into one term. That's going to be 9 times 5, or 45. Times the x that we see here to the 4th power. And the rest of the factors are big quantities, big quantity kind of factors. So x squared plus 7 cubed is that first one, and x to the 5th minus 2 to the 8th is the last one. Okay, it's time to take each set of factors and see if there's a common thing in both sets. 6x and 45x to the 4th. How about the 6 and the 45? This is always the toughest part for me. 6 and 45 have any common factors. I don't think 6 goes into 45, but 3 does, and so does it for 6. So I'm going to take out a 3. Also, I go check these x's. I've got x and a 4th power of x, so this is going to be a chance to take out just one x. Oh, and you know what? I'm forgetting my cross-out method. It really does help in the end of this. So let me go back. The 6, and I factored out the 3. I factored it out, so that means there's a 2 as the second factor. I'll cross that out and put a 2. And as far as the 45 goes, 3 goes into 45 15 times. So that's my remaining factor there. The x was also pulled out, so there's no x's left in this one. And there are how many left in this one? That 4 is down to a 3, so you want to put a little cube there. Okay, now these crazy quantities. This quantity here to the 9th power, do I also have it in the other set? It's right here at the end. It's the same. Is it the same? It's not the same, you guys. Darn it, I think I have a typo. Shoot, I do have a typo. I totally have a typo. I don't know, I wrote them though, so I don't know if you can call it a typo, but I do want you to change this. Let me see which number needs to change. This one. Oh, I don't have a typo. I just didn't write it down correctly. Silly. Okay, this should have been a 5th power. My goodness. So that's a x to the 5th minus 2. All right, I was about to panic. All right, let's get back on track. So we're looking at the x to the 5th minus 2, and we see its match here, but we have differing powers. So we're going to take out the smaller of the 2 powers. We're going to take out the 8th power for that one. X to the 5th minus 2 to the 8th power. Now let me go cross out what I still have. If I had 9 and I took 8 out, then that just means I still have 1. So I'll just cross out the 9 and let that be the 1st power. And as far as this one goes, all 8 of them came out. So that's all entirely gone. All right, the last one is this x squared plus 7 quantity, and the matching quantity here. We take out the smaller of those two powers, which is the 2. So I'm going to take that quantity squared. If I take it out, it's gone from this set, and it's reduced this 2 down to a 1, so I just have that single factor left. Okay, now we sit back and we write down whatever we have left after pulling out the GCF. So the coefficient is a 2, and I have this quantity, and that's it, 2, and the quantity x to the 5th minus 2. Bring down that plus sign. And what do we still have here? After crossing things out, we still have the coefficient of 15. There's an x cubed hiding right there. Don't lose that. And this quantity. So we got a couple things going on here. 15x cubed and the quantity x squared plus 7. That finishes the leftover factor. Now, just as we have before, we're pretty much done with these, but we need to simplify what we have in the leftover factor. So you're going to need to distribute any multiplications you have. 2x to the 5th minus 4 right there. There's another chance right here. You got to distribute this one through. 15x cubed times x squared. That's 15x to the 5th. And 15x cubed times 7. 15 times 7. Oh, here we go. We're testing me now. 15 times 7, 105. I'm hoping, I'm crossing my fingers because I don't have my calculator. Well, I do have it. I just don't want to pick it up. So hopefully that's 105. And x is to the 3rd there. Okay, you can check me. Bring down that plus. Check for any errors. And combine any like terms. There's a couple of x to the 5th power. So let's combine those two there into 17. X to the 5th. Next I'm putting these in order, 105x cubed, and then the negative 4. All right, I'm done with that, but I got to bring the rest of these down. Let's carry this all down. All right, now we find the zeros. Yeah, after we did all that, we're still not done. Can you believe it? All right, we're going to find the zeros. This equals 0, one factor at a time. 3x equals 0 is going to require x to be 0 for our first one. Circle that so you don't lose it. Here we have some fun stuff going. Okay, x to the 5th minus 2 means x to the 5th equals 2. And so x must be the 5th root of 2. So I'm going to put the 5th root of 2. And multiplicity is 8 on that. So this is a times 8. This is an insane problem. This is, I think my calculus students would even roll their eyes at me with this, but I did make it up, so sorry. It's kind of bad. But it shows some good stuff. This one, it really shows. I wanted to make sure you saw this. So x squared plus 7 equals 0 means x squared equals negative 7. If x squared is negative 7, you're not going to be able to square root it, are you? So that is a no real solution for that factor. That factor doesn't that factor doesn't provide any of the zeros. And I hope you've been excited about this one. We are going to solve this by using our PolySolve calculator formulas. So you might be thinking, why didn't we just use PolySolve from the very beginning? Wouldn't that be easier? The answer to that is you wouldn't be able to because it's in factored form up here. Well, kind of. Each term is factored. If you wanted to use PolySolve, you would have to multiply and expand all of that out. And if you want to do that, go ahead, get started on it. I'll see you in a couple of weeks when you're done, and we'll check it out. Okay, but here we have this factor alone. We can set that in a PolySolve. So remember, your PolySolve is an app. Go to Apps. Find it in your list. My list is long. I'm going to go to alpha P, and it will jump me to the alpha, or to the P's, and there it is right there, the Poly Simultaneous Equation Solver, PolySolve, or PolySmolt. All right, so go through the menu there, hit number 1, and let's look at the degree of our polynomial. The degree is 5, so make sure you have that as the order. Mine's already like that. And let's just hit next right here. And what is our, let me move this so I can see it. What is our lead coefficient? Enter that in 17. We're going to put 0 in for the 4th degree term because we don't have one. But 105 goes in. I really hope that 105 was right. 105 goes in for the cubed term, 0 for the squared term, and 0 for the linear term. Not till we get to the very end do we have the -4 as the constant. All right, let's hit solve and let the calculator do its thing. It's thinking hard. All righty, so we have these 5 roots, or 5 zeros. I'm looking right off, I see these ... dots. You guys know that that means those are imaginary, that there's more after that, with the I all the way at the end. So there are 4 imaginary answers. We only want the real one, so this is the only solution I want from that factor, 0.334. All right, that's going to be my final 0 for this problem, which is a good thing because I'm out of room, I'm out of voice. It's kind of getting a little bit sore, my throat here from talking so much. We won't circle that one. We've got these roots right here. Those are the zeros. So that's what I want you to practice today. Now, I am really curious to see if my 105 was right, because if it's not, I might have to redo this whole video. So let's just check that. That was, what was 15 times 7? Oh, phew. I'm good. Okay. It's kind of sad, but that little 15 times 7 was the hardest part of that crazy problem to me. So hopefully you'll get this good too. This is freaky factoring. Good luck with it. You got to give it a try. I'll see you soon. And P.S., the rest of this is on another video. We'll do that tomorrow. I'll talk to you later. Bye.